So, more antiderivatives. I started to write out a couple rules, but now I'm a little more organized here. I mean, you start with the book. The book has a list of a lot of beautiful rules. If it's your derivative rules written backwards, kind of. So the derivative of a constant was 0. That was one of our rules. Well, here's a rule that says the antiderivative of 0 is a constant. Remember that C is an arbitrary constant. That doesn't come up too much. Here's one. The K is a number or a constant also. The integration of some constant is kx plus c. I guess that's right. What if you took his derivative? You would get some number k. And here's the power rule I discussed. I said this is a big one. We got to do some examples of that. But these are really important also. These are kind of funny. This says if you have a multiplied constant, a constant multiplied by your function, you're allowed to pull the multiplied constant out in front of the integration and then integrate. We would do that with derivatives at times. So it works with antiderivatives. Here's another important one. If you're integrating a function plus or minus another function, now, when you're adding or subtracting, these are like separate terms, or two separate functions is the way this rule is stated, added or subtracted. Then what it says here is that you are allowed to sort of distribute the integration to separate terms. So you're allowed to integrate the function f of x and then add or subtract it to the integration of g of x. So you're allowed to integrate term by term. We would do that with derivatives also. With derivatives we had a product rule and a quotient rule. We don't really have that with antiderivatives. We don't have that until we learn some advanced things, but they're not really, there's no product rule or quotient rule. So we need to just integrate separate terms. If this was multiplied, there's no rule for that. You can't just do that. But added or subtracted, you can integrate separate terms. You can pull out multiplied constants. You never pull out the variable. So these are nice, handy things. Let's practice a couple power rules. So if I have the integration of x to the third, the answer is, according to the power rule, it's easy. You add 1 to the power, it's x to the fourth, divide by 4, plus c. Sometimes I would just call that 1/4 x to the fourth, or x to the fourth over 4, same thing, plus c. You can check it by doing the derivative if you want to check it. I never check it, but multiply the 4 down here, it cancels, subtract 1. I just did a derivative and found this derivative, but this is the antiderivative. Watch this, they get a little, this is interesting. When you have something like this, or here's another classic, something like this. So, if you look over here, there's no rule for this, except, wait a minute, and there's no rule for this, really. But, wait a minute, can you write these as x to a power? And yes, you can. So the power rule is huge, and it applies to a lot of things. We can rewrite this square root of x, you know this. You can write it, we did this with derivatives, we can write it as x to a power. And now I can apply the power rule. Let's see what that is. Add 1 to it. When you add 1 to that, it's x to the 3/2. Is that right? Yeah. And then you divide by 3/2. That's about the last time I might do that. When you divide by 3/2, I'd rather say multiply by 2/3. Dividing by 3/2 is, so I'm going to really write this as x to the 3/2. Oops. Sorry. I would write this as x to the 3/2 multiplied by 2/3. Now, did I forget anything? Oh yeah, the plus c. Sorry, plus c. Yep. Dividing by 3/2 is the same as multiplying by 2/3. Look at this one. Can you write this as a power rule? You don't do a power rule in the denominator. It has to look like this for you to do the power rule. So of course, you move it up. We did that with derivatives. You move it up first. Your book says you rewrite the integral, then you do the integration, and then you clean it up. So that's what we did here. We rewrote the integral, we did the integration, then we cleaned it up. Notice when I do the integration step, I don't write the integral symbol anymore, From here to here, I was rewriting the integral symbol is still there, and then I did the integration step, I did the power rule, and the integral symbol goes away, the dx goes away, you get your answer. So I rewrote this as x to the negative 3. Let's try to do this power rule. Add 1 to it. X to the negative 2, divide by negative 2. So that's the answer, plus c. If I rewrote, that's the answer. If I rewrote that, I would leave the negative 2 in the denominator, but I'd move the x squared down to the denominator. And, you know, I like to put the negative sign in the numerator, actually, so I would write negative 1 over 2x squared plus c. That's the antiderivative of this 1 over x cubed. Now, there's one of those, I'm going to keep talking here a second. There's one of those that fails the power rule. So there's a lot of good power rule examples. There's one of those that fails. It's this one, 1 over x dx. And maybe you know who, there's a famous function, and the derivative is 1 over x. Yes, it's natural log of x. The answer is natural log of x. If you tried to do a power rule, it would fail. Let me show you. If you tried to do a power, don't do this. If you tried to do a power rule, it would fail. What would you do? Oh, you'd add 1 to that. There's nothing wrong with x to the 0 when you add 1 to that, but then you're supposed to divide by 0, and that's where it fails. So the power rule fails. You don't get an answer doing the power rule. This particular example is not a power rule. This is the natural log function. We put absolute value on that because we want the input to be positive for the natural log. Natural log plus c. There was 6 trig rules, 6 trig derivative rules. Well, there's 6 trig antiderivative rules. So I could write all those down for you. They're in the book. We talked about cosine in the last videos, e to the x. I mean, those are just some standard basic rules. Now, let me show you something else here. So now with all these rules, and I did some basic power rules, but with these 3 rules, I want to show you something. You can integrate any polynomial. If I had 4x cubed minus 7x squared plus 8, just any polynomial. Now, according to this rule down here, you integrate each separate term. So these are really separate integrals. And you're allowed to pull a multiplied constant out front, but only out in front of his own integral. So like you're not bringing this 7 out in front of this. No. So you have 3 separate integrals here. You have 4x cubed dx. You have a negative 7x squared dx. And you have another integral, 8 dx. And then you are allowed to, you're allowed to pull these constants out, multiplied constants out front. So I can pull the 4 out front. I can pull the negative 7 out front, multiplied out front of the integration. I can pull the 8 out front. And now I can do these integrals. I can do the power rule. So that is x to the 4th over 4. That's the power rule, multiplied by this 4. I could say plus c. I'm not going to. There's x cubed divided by 3, x cubed divided by 3, multiplied by the negative 7. I could also say plus c, but I'm not going to. When you integrate a 1, you get an x, multiplied by the 8, so you get an 8 times x. And then, like I sort of was joking, this could have had a plus c, this could have had a plus c, this could have had a plus c. But then I would have added all those arbitrary constants together, and I would have put just a nice big plus c on the end. So that's what I wanted to do. I just used these 2 important rules here. I'm erasing them. I'm sorry. I need some room here. But I use these rules where I can separate each term and do 3 separate integrals. I can pull out multiplied constants, and then I applied the power rule to each of these. I did that to illustrate the use of the rules. The truth is, in real life, man, you just integrate each term. You do that kind of stuff in your head. So you just do this power rule. It's x to the fourth divided by 4 cancels. It's x to the fourth. That's where this was headed. You do this guy, x to the third divided by 3, negative 7/3 x to the third. You do this integral of an 8. That's an 8x plus c. So the truth is you just do this. But you're kind of doing those other two important rules in your head. You're doing these rules in your head. You're pulling out multiplied constants. You're doing the power rule. You're putting the constant back. You're doing 3 separate little integrals. So I'd like you to get that concept. All right, you're well on your way to doing a bunch of homework in 5-1. This is important stuff. This is important for Cal 2. This is we need to know how to do antiderivatives. There's a lot more to this chapter. There's a little more in 5-1 actually. So good luck.